In this video lesson, we will look at exponential equations that are in quadratic form. So for the first example, when we look at this and decide what are we going to do to solve it, normally we've seen that if the exponents which contain x are perhaps in two terms, what we could do is we could break them up and factorize them out. So what will happen if we do that here, because we have 2x, when we break this up, this becomes 2 to the power of x times 2 to the power of x, because if you multiply the same basis, you add the exponents and it becomes x plus x, which is 2x. And then plus 7 times 2x equals to 8. Alright, so if I do factor out 2 to the power of x, we're going to have a problem because there's still going to be a 2 to the power of x left. So that would look like this. Now, if this was a 0, that would have been fine, because then we could have just said this is equal to 0 or that's equal to 0 and solve them separately. But since this is equal to 8, that's not going to work. So we're going to have to come up with another plan. And when we look at quadratic equations, they are normally, for example, like x squared plus 5x plus 6 maybe. You'll notice that the exponent, this one, is always double this one. So this actually resembles this format, this standard form. So we can try and factorize that using quadratic factorization rather than taking out a common factor. And to do that, we need to actually put it in standard form first. So that means this 8 needs to go to the other side. And also another thing I'm going to do is I'm going to rewrite this rather as 2 to the power of x squared, so that it comes through as squared, and then you'll just have, like, for example, the x there. Plus 7 times 2 to the power of x, I'm just going to put this in brackets, minus 8. Okay, now to make this even more clearer, we are going to just, this is optional, but you can rather write it as k squared plus 7k minus 8, because that is far easier, or that you can obviously see is easy to factorize. That just becomes k plus 8 and k minus 1. Okay, so now the factorization is done. You can basically just replace the k again with 2 to the power of x. So this is going to be 2 to the power of x plus 8 and 2 to the power of x minus 1. 2 to the power of x minus 1. Okay, and then since this is equal to 0, we can now say 2 to the power of x plus 8 is equal to 0, or 2 to the power of x minus 1 is equal to 0. So solving for these individually, we have 2 to the power of x is equal to negative 8. We know 8 can also become, or we can change that into the same base here. This is negative 2 to the power of 3. But now there's a small problem, and it's actually the sign. When this is a negative, that's positive, there will actually be no solution. We can't change this. This won't say that x is 3 or x is negative 3. This is literally, there's no solution. So we're just going to have to write no solution. That happens if this is a negative. On this side, we have 2 to the power of x is equal to 1. This 1 we can change to a base of 2 by writing it as 2 to the power of 0, and therefore x is equal to 0. Alright, so that one is solved. Then we'll just do one more example, example 2. Now this one is slightly more complicated, but the most important thing is we notice that this is to the power of 2x, where this is to the power of x, and this is not 0. So this indicates quadratic factorization. Okay, but before I start, also this I'm going to do like I previously done with the other common, taking out a common factor. I'm going to break this up first. So we're going to write it as 2 to the power of 2x times 2 to the power of 3, and then plus 10 times 2 to the power of x, and bring the 3 over so that we can put it in standard form. Okay, and then again, this I'm rather going to write as 2 to the power of x squared. And also this thing is actually the coefficient, so I'm going to move it to the front. And 2 to the power of 3 is equal to 8, so I'm going to write 8 times 2 to the power of x squared. Okay, so that's that, and that I just rewrote as that. Then plus 10 times by 2 to the power of x, I'm going to again put this in brackets, minus 3 equals to 0. Okay, and if you want to, you can replace it with k again. 8k squared plus 10k minus 3 equal, well, we'll just factorize now. So that is factors of 8, 1 times 8 and 2 and 4, and on this side factors of 3. So one of the sides I want to swap around so that I just have all my options, and then plus 10. Okay, now this one is actually one that you need to be careful for, because we can say 2 times 3 is 6 and 4 times 1 is 4, which can give us 10. But the problem with that is to get 10 you have to say plus 4 and plus 6, and the signs are the same, but this is a negative, which means our signs here need to be opposite signs. So there needs to be another solution. So we can also say 4 times 3, which is 12, and 2 times 1, which is 2. So that gives us plus 12 minus 10, minus 2, to give us plus 10. So our solution then is going to be 2, okay, this is the plus and this is the minus. So it's going to be 2k plus 3 and 4k minus 1. Okay. So in terms of 2 to the power of x, I'm going to write 2 times 2 to the power of x plus 3 and 4 times 2 to the power of x minus 1 equal to 0. And then we can say 2 times 2 to the power of x plus 3 equals to 0, or 4 times 2 to the power of x minus 1 equals to 0. And then solving for this side, we have 2 times 2 to the power of x equals to negative 3. Divide both sides by 2 is negative 3 over 2. So obviously this can't be changed into the same base, but even this is negative, so therefore it would have no solution. On this side we take the 1 over, becomes 1. Divide both sides by 4. 2 to the power of x is equal to 1 over 4. This I can change into 2 to the power of 2 to get the same base, 1 over 2 squared. Then I can take the 2 squared up to make both bases the same. So 2 to the power of x is equal to 2 to the power of negative 2, and therefore x is equal to negative 2.